So welcome everybody. We're going to do our first night hacking panel interview. Hope you guys are enjoying your lunch and had some good sessions after the keynote. With me, I have several panelists who we'll introduce shortly. We're going to try to divine if the internet is really ready for devices or not, because there's certainly a lot of hype about it. I'm sure you guys have heard things. We have folks on an online stream. What you see up behind me is exactly the same thing, which is being broadcast at nighthacking.com. So we have a bunch of folks watching this live from the live stream. They're going to be interacting via Twitter, via hashtag nighthacking. So we'll post questions from those guys. Obviously, if you're in the room here, you don't have to use Twitter to interact. You can just come closer to the stage and ask your questions directly to the panel, and I'll repeat it for folks on the stream. So, sound good? You guys ready for the panel session? Yeah? Okay, we need to add filler applause there, so. All right, so just to set the stage, the Internet of Things, which is all about devices and small embedded things that can communicate, interface with the internet, with back-end cloud services, and change the way that people are interfacing in their lives with wearable electronics and different things. It's received a lot of hype in industry analysts projecting 10 billion devices and more coming up. If you look at all the companies investing in it, even here in the pavilion, they have the Lego Mindstorms over there, which runs an ARM processor. I know at Oracle, we're doing a lot of work on embedded. And there's also some other device manufacturers here which build chips. So the question is everybody ahead of the game? Are they trying to put money into something which isn't quite ready yet? Or is this actually a technology which you can apply today and actually make use of? So we got some practitioners here, folks who actually work on the technology. And we're going to chat with them today and see what their opinions are about the state of embedded and Internet of Things technology. So, starting on my left here, Gerrit Grunwald, would you care to introduce yourself?
Yeah, I can introduce myself shortly. So, I'm a software engineer, studied physics, working for Canoe Engineering in Switzerland. And I came to the IoT thing just because I'm interested in the physics behind it and in the semiconductor stuff, and it was just natural to use Java to code for that kind of devices. So
it was a happy accident.
Yes, very happy.
All right, Mark.
Hi, hello. My name is Mark Heckler. I am a software engineer with Oracle. Work out of the St. Louis, Missouri, USA office.
All right. Mike, let him borrow yours.
And that was going so well until then.
Yeah.
My name is Mark Heckler. I'm a software engineer with Oracle. Out of the St. Louis, Missouri, USA office. Work more on the server side of Java, but the Internet of Things has become a passion of mine. So I've been, as we said in our talk earlier, kind of pressing against all of the edges I could find to see where they lie and see how far out we can push them. So that's, in a nutshell, it.
Hey, I'm José Pereda. I'm from Spain. I work at the university in Valladolid. I'm an engineer, but my passion has been for several years coding and applying this coding to actual projects, real projects in the industry. So besides that, I tried the embedded stuff for many long years in this industry environment. And now I have the pleasure to share my hobby hours with Mark, playing with the Raspberry Pi, the Arduino, and all the things we can find in the IoT environment. So this is it.
Cool.
I'm Joakim Eriksson, working at the Swedish Institute of Computer Science with networked embedded systems, like these ones, really small devices. I'm developing low-level C most of the days.
You held up a device. You have to tell us what you held up there.
This is Cortex M3 based, really small system on chip with built-in radio. So in this, you have 256K of program memory and 16K of RAM, which is a huge device for me, small for anyone else. But here you can run a full IPv6 stack, routing protocols, web server, and more or less anything you like. Soon, I hope, Java also. So I'm working with this on a daily basis, low-level C, but also on the gateway side and cloud side, of course, Java and other technologies also.
Okay. So just to set the stage, so you have some devices, Jose, which you'd like to demonstrate to us, and give us an idea of what sort of things you're showing here. Help him with the mic while he's showing devices.
For starters, most of you should know by now about the Raspberry Pi. Okay, this is a Raspberry Pi within a case and a camera. It's a very little tiny camera, but it's 5 megabytes of resolution. It's really huge resolution for this device. Okay, this is an Arduino. Most of you will know about an Arduino, for sure. We have this morning the keynote with David Cuartuelles, one of the creators of the Arduino project. So this is another tool from Italy. It's an OpenPicos project, and this is a FlyPort with Ethernet and web server embedded. So you can apply many seals to build something more sophisticated with your boards. So these are Ethernet seals, and these are ZigBee protocol antennas, and the seal for plugging into the Arduino. Well, I have plenty of these at home and play with them. But you know, there are many things, many devices out there, and maybe Gerrit will tell us about all the devices he has at home.
Well, you know, so the IoT that I use is for Joachim. It's more supercomputer size. So it's in the gigahertz range. Dual core CPUs. You have megabytes of RAM. You can run Java SE, which is with JavaFX support. So this is nothing that will run on these very tiny Cortex M3 devices. But the hurdle to start with is so low that every Java developer can really easily start to code with that stuff. And that makes it so much fun. In principle, this is not new technology. This is things we knew for years, but now it's so small and so cheap that you can just buy it and attach some sensors or actors at home, and that's the fun part of it. And that's where I started with this. There are different devices on the market right now, like BeagleBone Black or QB Board, or I don't know. There are lots of devices which have several similar specs, and that you can buy for around 30 to 40 bucks.
All right, so here's a question for the panel. Actually, one of the folks online, Jim Weaver, asked us a question over Twitter, and he was interested what sort of cool projects that you guys are working on. And I think this is really directed, it sounds like you guys are the hobbyists. You're kind of hacking and playing with the technologies. And it sounds like you actually have real industrial applications which are applying the embedded technology you're working for. So let's start with a good hobbyist. What are you doing, Gerrit?
Okay, so first of all, I also worked as an engineer for the semiconductor industry, and there I used also embedded technology based on Java using the sunspots, which are a little bit old now, but also ARM-based. And I used them to monitor the temperature and other values inside of a semiconductor lithography tool, and to monitor the temperature and visualize it on my desktop. So I have a little bit experience of this professional usage of IoT, but at home I'm using it mostly for monitoring temperatures, humidity, pressures. I have some actuators to switch on off light and all that stuff. So location awareness I'm now working on. The interesting thing is you can combine all these technologies suddenly just on your desktop using these small devices talking to each other. So that's what I'm doing. It's too many things to go into detail. So I think these guys have more detailed information.
Well, I guess, Jose and I have been working together on... Closer? Okay. Jose and I have been working together on a couple of different things, but probably the most fun one has been putting together a renewable energy system that is monitored and managed by an embedded system using Arduinos, Raspberry Pis as clients and remote concentrators, pushing as far down the platform scale size as we can, even putting a Java EE web profile on a Raspberry Pi to run as a data server, and using WebSocket to tie it all together to where we have a globally networked system where we exchange data and record it live throughout and control the system, lights, heat from anywhere. I also have just started working recently on drone software and some autonomous software for drones. So that's something I'm looking forward to getting more into after JFocus.
So you both mentioned that you're doing a lot of lighting and heating and things with your houses. So what happens when there's a power outage?
Well, you learn the value of a good UPS. I guess that's the first thing. In a lot of this, when you're testing new configurations, you try different things, you switch configurations around. And recently we had a massive power outage where I was, and I had just changed my configuration to pull some things off the UPS and wound up scrambling and rebuilding some systems. But the UPS helps smooth a lot of that out, as well as when you have a sufficiently large storage array, battery storage array, then that can insulate you from a lot of that as well. But yeah, as with anything, good backups are a key.
So it's kind of like the difference between manual car windows and electronic power.
Yes, although I have to tell you, after that, I really seriously considered the hand generators for a while,
generator.
because at least that would have kept things going when things got a little dicey with the UPS. So yeah, lesson learned.
So one of the most exciting projects I'm currently doing is to port this small operating system that we run on these really tiny microprocessors to one platform that happens to be inside this. So it's basically this plus power switch and electrical metering. So this device runs the same software contiguous as we have in these kind of open electronics devices, and actually it's going to be a released product soon. So it's going to be more than hype fairly soon, I would say, in more realistic devices.
So do you see people having those devices all over their houses or
This
their
will-
businesses or?
This will probably, I mean, we've seen a lot of these devices already selling quite a lot for smart home applications. And this will be the first generation of that, but this time all IP all the way to the devices, so you can actually ping your thing, basically. You can, in the long run, I think this will be built into the walls instead of actual additional sockets, because it would be nicer to hide it away. But also we have some other projects more on higher levels, connecting different types of systems like heating system, burglar alarms, ventilation, so that these services can work together. Today, they're typically one service per system, which make them not really optimal. So you need to, when you kind of puts on your burglar alarm, the heating system could start slowing down and the ventilation to avoid burning unnecessary energy. So there's a lot of interesting things when it comes to how to handle these, how to connect different types of services over the internet also.
Okay,
That's,
so you mentioned something interesting, burglar alarms, and that ties in with the general security concerns people have with Internet of Things. So if your house is now on the internet and it's communicating with different systems, if I'm a thief, can I just hack your house and then break through your security system?
Sure, that's the problem. It's actually, I mean, what we need is probably something even higher than typical credit card security, because that's easy to hack. You could guess numbers, security card numbers more or less today, and steal people's money. That's handled today, but it's worse if they turn off your heating system. So security will be a key issue. Before we have security, IoT will actually just be a hype. So it's going to be very important.
Cool.
I had an experience with just a small example of what may happen, because in our demo we had all our devices at home working, So we try to show them working on the slides. So for that, we need to get access to our home and open our router, open the port, so we can get with BNC or SSH or whatever to our Raspberry Pi servers and so on. So when I was at home, I opened all the ports to test it. When I was working, I log in and check everything was working. But suddenly one day I couldn't get into my Raspberry Pi through a BNC server because there were it's true, there were several bots out there trying to get into this BNC port, which is a regular port, and the server blocked the connection because of the many attempts they were doing. So I have to change the number of the port to a different random port to avoid that. But these things happens because there are many bots out there scanning for ports and everything like that. So
You want to add something, Garrett, about security?
No, I agree.
Okay, so we've talked a lot about different devices which you can use. So one of the questions, we have a lot of Java hackers. Who here is a Java hacker in the audience? Raise your hand. Yeah, any Java hackers?
There's one.
Any shy Java hackers? Are you a Java hacker, Mateus? So for folks who are developing on Java, what are their options for doing embedded development today? What can they actually play with and build with?
Well, I'll throw in what I think is the easiest. Raspbian now, as of the announcement was made at JavaOne 2013, feedback, that Raspbian will ship with the JDK. So you've got Java SE embedded that comes with every build of Raspbian that you can download from the raspberrypi.org. So that's a great place to start. And if you decide that you want to look at ME, or if you decide to look at, as in our case, we actually deployed full Java Enterprise Edition with Glassfish 4, so Java EE7 web profile. You can build off of that. So I think it's a great place to start, very approachable, something that you're used to. The APIs that you're used to are already in place. You just install the OS and you're off and running.
Yeah, you can also start with, for example, Java ME Embedded 8. For around 16 euros, you can buy a board from ST Microelectronics, which is supported by Java ME 8 Embedded. And so this is just a tiny device, or you can also get devices from Gemalto, which have most of the time embedded 3G connectivity. So that means you can build your device, put it somewhere, and add a SIM card to it, and then it can connect to the internet. And all these things are running on Java ME embedded. And then you can use things like the QB board that I mentioned already. So all where you can run Raspbian, which is a Debian Linux, there you can use JDK8 SE embedded. So that's really an easy start and really cheap.
Cool.
Actually, there is a problem with the Raspberry Pi, which you cannot load your usual or regular ID there because it's not so powerful to run and open, for instance, NetBeans or Eclipse or whatever. So for now, there are tools for instance, in NetBeans 8 beta, which you can download now, that allows you to get to the Raspberry Pi, but running everything on your computer, from your computer on the Raspberry Pi. So you can not only deploy and send your programs, your jars, to the Raspberry Pi, but also you can debug from your computer on the Raspberry Pi, which is very useful when you are deploying your program. So it's a really great tool for that.
Okay, you want to add last comment?
Yeah, I mean, Raspberry Pi is really a nice platform, but I consider it being a good Internet of Things gateway, and then you could connect a bunch of other things.
You would consider the small chips, those endpoints, the real Internet of Things.
These are the really small endpoint. Could be your temperature sensors or things like that, humidity sensors, CO2 sensors, and then hook it up to your local Raspberry Pi and do some nice processing in Java and do some intelligent decision making, controlling your home. So that's That's one way of doing Internet of Things with Java. Or you build a bunch of devices using Raspberry Pis because they're cheap enough to actually use several of. But if you would like to produce your temperature sensor smart device and then start production, you need to go down where Java is not yet. But I'm kind of trying each year at JFocus to tell Oracle that
Yes, Java keeps getting smaller.
Yeah, and
Java ME sits on really tiny chips now.
Yeah, so I think there's hope. These devices get slightly larger. They're being moving from 8 bits to 32-bit ARM processors, so it's easier to scale up. And as Java is scaling down, soon they will meet, I hope. Then it's going to be much easier, because if we would like to see these 50 billion devices 2020, I think it's really important to get a higher level language on these devices, because we don't have enough low-level C programmer. I think no one would really like to convert. So we need to get Java or similar onto these devices to truly scale up to this and make 50 billion devices before 2020. That's
Okay, so speaking of devices and gateway devices where you might want to have more interaction, we got a question on the stream, and it was how JavaFX enables IoT applications. Guess who it's from?
Yeah, so yeah, you can use JavaFX on the Pi, for example, and like you mentioned already, it's the Pi. There's a great device working as a gateway or to visualize the data that it collects from a sensor network, for example. There you can use JavaFX really nicely. And there are other ports like JavaFX on Android and on iOS, which are not officially supported, but I have actually this watch on my wrist, which is running Android, and I have a JavaFX application running on that watch. So that shows the capabilities. This is, like I said, this is just not official. And
all right, so I think you're the first person we have here with wearable technology on our panel.
Really? Wow. It's not that excitant anymore, right? So this stuff is available.
All right, so why don't you talk a little bit more about the watch and what it is and how you
the
run
watch, yeah,
JavaFX on
the
it.
amazing stuff. This is the watch I ordered from Hong Kong. It's 140 euros, so really not expensive. This is in principle a mobile phone completely. It's running Android on an ARM9 dual core, 1 gigahertz, so it's really impressive. And you have a touch device, and so you can really do a lot of things. It's amazing what you can do with such a cheap device, right? So if you can, I don't know if you can show it. Oh yeah. So let me switch it on, and yeah, it's. I think it will be hard to see, but just let me take it off, and then I can show it to the camera. So let me show this one. Just give it a second to boot up. And here we go. So this is a JavaFX application running on the watch. And as you can see, it's not that slow. So this is something I created in JavaFX, and it's the same code I use on the desktop. I can also use on that watch. And I can also use it on my, for example, on my iPad or whatever. So I have no data here because I'm not connected to the network. But you see that I can do these things, and the animations are quite smooth. So it's really nice to do that kind of stuff. Even the graphics are there. These are connected to my Pi at home, so it measures data from my Pi and visualizes it on the watch. So yeah, this is that's 140 bucks, and it's really powerful. So you can do, and this is also IoT, right? If you be honest, then every smartphone, every iPad, it's ARM architecture, so that means it's in principle the same, just more powerful than these tiny devices, but the base is the same and the idea is the same. So for me, it's the same thing. So mobile and embedded is in principle one thing, I guess. So that's my thought.
So any of you guys up doing any UI work with IoT, user interfaces?
Yes. For our demo, we built, in fact, two IoE clients, one in JavaFX and one with JavaScript. And the funny thing is that with the help of the designs by Gerrit, it's very easy to run the JavaFX client on every device, and we run it also in the Raspberry Pi. So it's really easy to mix the client with these devices, because though they are in the backend, you have plenty of ways to communicate the client with your backend, with your server. So with Java, you can do the full stack. You can go from the backend through the server to your client, and you can wear a client actually, or have your desktop or any kind of device you want. So with JavaFX, it's really easy to adapt and to mix all these devices. One thing you have to figure out is the way to communicate between each other, and you have two main streams. One, getting the data, which is really easy. Get everything from your sensors, all the readings displayed in gauges or whatever you want. And the other thing is controlling real devices at home. So you have to establish two ways to get in touch with your devices. One for readings, and one actually for writing on digital pins to trigger some action at home. So with your client, you can do both things. And put some buttons, some switches, or something like Gerrit has shown, to easily interact with your devices. It's really fun.
Okay, so we're getting close to time when sessions are going to get back in, but I want to get the panel, our expert panel's poll. So 5 years from now, how much of JFocus will be embedded? Because right now we have a conference full of Java sessions, and there's a small embedded track. So 5 years from now, what's your prediction on JFocus embedded?
That's a hard question. I would say that we will still at least have one track, but also, since I assume that we have more Java in many more embedded devices, it might actually pop into the general sessions. Like we had some Raspberry Pis on some performance testing. So I think maybe we might not consider splitting the topics anymore. So it might even merge into being more of the same. So of course you will not run enterprise Java on an embedded system, but I think the programming, the way to program an embedded system needs to be closer to actually programming your desktop or your mobile phone. So I kind of hope that it's rather going to merge in and to be part of it, at least, going to be in the other sessions also.
Okay, I have to agree with Joachim for that. And the good thing in 5 years' time, it would be that we don't need to talk about something called IoT or embedded stuff, because it would be so sadly to say that we are still talking about a new thing, because in 5 years' time it should be all embedded in our real lives. So I guess it should be another mainstream also, like the other ones right now.
Yeah, I was going to say almost the same thing. In the IoT keynote this morning, David mentioned that IoT, the Internet of Things, is really machine-to-machine computing for the common person, for the everyday person in the world. I think that as it becomes more pervasive, it will just be something that will be incorporated into every system. If you think about the number of wearable items, or the number of wired or wireless, I should say, items that communicate that we use daily already, it's kind of staggering, and that number is just going to go up. So I think it's going to take on a much larger role. I don't know that it's going to be talked about as much, because it's going to be just an accepted part of everything we do.
You got the last word, Gerrit.
Okay, so yeah, I think at the moment it's the hype, right? IoT is the hype, everything is IoT. And in 5 years, my prediction is then it's just there, and nobody talks about it anymore, because it's everywhere, right? It's just part of it. So then we have another hype. I don't know what it is, but
The next big thing.
yes.
And you'll be doing it.